Hello, this is Miss Williams, and we are in Accelerated Algebra 2, Topic 6, Lesson 5. Today we'll be talking about properties of logarithms and being able to use those properties to rewrite the expressions. You'll need your vocab sheet out because we'll have one vocab, but it's more towards the end in that change of base formula. Okay, so we're going to start with the warm-up today. And I want you to look in on the graph. Okay, so if y equals the log of x, here's what it looks like. Here's some values shown as the ordered pairs. Okay, so just do this either you can have on your note sheet or write on your desk if you have the whiteboard marker or on a scratch sheet of paper. I just want you to fill in this chart. Okay, what would be those values? Okay, and you should have just written the values that you see. Okay. Now, what I would like you to do is, what is the relationship between the numbers 3, 5, and 15? And then how does that relate to the relationship of the logarithms of 3, 5, and 15? Okay, so remember this is the log of the x. So log of 3, log of 5, log of 15. Then if you could predict, what would you predict using that maybe to find the log of 45 or the log of 75? Go ahead, pause the video. All right, welcome back. So let's talk about those relationships. So first, right, we should get that 3 times 5 gives us the 15. However, if I multiply those logs together, I will not get this answer. But if I take the log of 3 and add it to the log of 5, I will actually get the log of 15. Right? So if I take 0.477 plus 0.699, I would actually get my answer. So knowing that the relationship of multiplication, we're going to add those logs. So a prediction here could have been, so how do I get 45? I would take 3 times 15. So if I take the log of 3 and add it to the log of 15, I should get the log of 45, which would be 0.477 plus 1.176, which would equal 1.653. Okay, how do I get the log of 75? Right, then I would take 5 times 15, and so the log of 5 plus the log of 15 should give me the log of 75. And so we have 0.699 plus 1.176 is about 1.875. Now if I actually type that in, that is what I actually get. Okay. So how is this going to help us with our properties, right? So how are the properties of a log used to simplify expressions and solve logarithmic equations? Okay, so I want you don't have to write this down, I just want you to watch to show that Okay, we have x is going to equal the log base b of m, and we have y that would equal the log base b of n. Then that means that, right, if I were to change this, log base b of x equals m would give us this. Log base b of y would equal n, which would give us that. Okay, so which means that if I multiply b to the x times b to the y, well, that should be m times n. Right, if I just straight substitute this, right, this equals m. If I multiply these two together, I should be able to multiply those two together. Well, we know same base, right? I can add my exponents, so that should give me x plus y. Okay, now I want to change forms. I want to bring this back into log. So we have log base b of mn is going to equal the exponent of x plus y, which means that this log of base b mn, so two things multiplied together, is the same as, well, what was x? X was the log base b of m. What was y? The log base b of n. Right, so x from above, I just substituted that in. Here I substituted y and that. And so what this is saying is that the log, when we have the same base and we are multiplying, that is the same as adding the two separate logs. Now, why is that? Because remember, logs equal the exponent. So if I am multiplying two things of the same base, right? Same base, we're multiplying. What do we do with our exponents? We add them. Okay, so you can imagine, right, all the other properties are going to fall from this. Okay. So here are all your properties. They are looking at these are the ones that you should be writing down. So product property, quotient property, and power property. Okay, so these are the three to start. But I want you to think product, so we're multiplying. So when we multiply, we add our logs. When we divide, we subtract, because that would be dividing, right, two things with the same base, we subtract our exponents. And then a power to a power, we would multiply. So I always call this a power to a power. We multiply, which means we're going to bring out front. Okay, so if you need to pause the video to go ahead and finish writing those, please do so. Okay, so I'm going to start with just some basic examples, and then we're going to build on them. Okay. And so, right, we have our log mn, right, same base, that is the same as we just decided of adding our logs together. Now, how does that look? That means, remember, this base has to be the same. Okay? And so then this, right, what does this become? Well, right now I'm just going to use any combination. It doesn't matter which one. But for this instance, I'm going to rewrite this as the log of 2 times 6. Okay, they're the same base. This is a base 10, right? And so that would be equal to the log of 2 plus the log of 6. Okay, so back here are our properties. So we have log of m minus the log base b of n. Okay, so that's the same up here. So you might have these properties already. That's the quotient, which means that we would be subtracting. Now I have a log, so I have a base 6, so I'm going to take that and say 5 minus log base 6 of 2. Now sometimes they're going to give you values for these, others that will be it. Okay, the last one is when we have a power to a power. So right, this would be an exponent to an exponent. So this is like saying log base b of m. This k is going to come out front, and that is going to be multiplied by. Okay, so this little k comes out front. So in this case, we would have our log base 2 of 3, but this 2 is going to come out front, and so it's 2 times that value. So this will be the difference between what we call expanding, making these bigger, or we're going to condense these into one number like these. Okay? Alright, so here are kind of the first one. So we have the log base 5 we got to look at. We got multiplication and we got some exponents. We're going to do two things at once. Okay, so first I want you to think, okay, we're multiplying. Let's separate that, which means that I should add my two logs. So I have log base 5 of a squared. I'm going to bring that all together, plus log base 5 of b7. Okay, so we're partly done. Then I want to take care of this exponent, so I'm going to bring it out front, and so we have 2 times log of 5a plus 7 log base 5 of b. And there would be my answer. Then, so in B, right, so you gotta think, okay, ln is our base, alright, so dividing would be the same as subtracting. So I'm going to expand this by separating them using subtraction. Okay. Alright, I want you to go ahead, pause the video, and try these. Okay, welcome back. Let's see how we did. So we have log base 7 of r cubed plus log base 7 of t to the 4th. And then those two pieces, right, are going to be minused by log base 7 of v. Okay. When there's groups, it's not a bad idea to put this in parentheses, knowing that those are going to happen first. Okay. Now, in general, because we're talking about adding and subtracting, this would actually happen truly left to right, and so we wouldn't have to worry about it, but it doesn't hurt to keep that in mind. And so we have then, we should have 3 log base 7 of r plus 4 log base 7 of t minus log 7v. Okay, here we would have the ln of 7 minus the ln of 225. So that is expanding out, right? We're making them bigger. Okay, on the test, I'm not going to have you rewrite this, so you should just be able to expand it and then circle your answer. Okay. All right, then we're going to go the other way. Okay, so I want you to think we're going to put this all as a single log, meaning right now I have 3 logs, but I want this to only be 1. And we're going to simplify this down. Okay, so any numbers that can be simplified, we're going to do so with powers, etc. Okay, so we have, when I'm looking at this, I'm going to put the 4 up. I'm going to put the 3 back up. So we got log base 4 of m to the 4th plus log base 4 n to the 3rd minus our log 4p. Now, what this is going to become, so I'm going to write my 1 log base 4. We got adding, which is going to be multiplication, so we should have m to the 4th times n to the 3rd. Subtraction would bring us to division, which means my p is on the bottom. And so there is my single log. Because I have variables, nothing will simplify. Okay. Down here, okay, now we got some numbers. We have the ln. So I'm going to raise this back up. Same with the 2. I usually take care of the multiplication first. So we got ln of 2 cubed minus the ln of 5 squared. Okay, so I got my 1 log, which is ln. Now I'm going to put this in parentheses, and I'm going to take 2 cubed, which is 8, over, because of the subtraction means division. 5 squared would be 25. Now this can't simplify. I would just leave it just like that. Okay, so this is condensing it or writing it as a single log. Okay, I want you to pause the video and go ahead and write and try these. Okay, welcome back. You should have put in the 5 up, 7 up. Subtraction means division, so your answer should be log base 2. Now, if these are not the same bases, you can't do this. They have to be the same base. And so we have c to the 5th over n to the 7th. Okay, we have 2 is going to come up here. And so we're going to have the ln. So I'm going to write this. We got 49 from this, right? 7 squared plus is times the ln of 2, which I'm actually going to multiply that out, right? So adding is multiplying. So 49 times 2, we get 98. And so that is my simplified ln. Okay, so being able to go back and forth. Alright, then we got our story problem, and how does rewriting this help us? Okay, so we're gonna be working these, we're applying the properties of our logs. So we have the pH of a solution is a measure of the concentration of hydrogen ions. This concentration measured in moles per liter is written as H+, and is given by the formula. So we have the pH equals the log. This is all in parentheses, I want you to think. Okay, so it says, what is the concentration of hydrogen ions in the acid rainfall? Okay, so concentration of the hydrogen, that's this H+, is what we're trying to find. So we got acid rain, we got a pH of 45. And so we're going to use this one, right? And so I'm going to bring this formula down. Okay, acid rain has the pH of 4.5. So I'm going to plug that in, right? And now we're going to try and solve this for h plus. So now how could this help us with properties? That's the fact that here I got my common log. Okay. I still could probably change this, but I still am going to have this idea of this 1 over. And so knowing that, I can actually separate this into two logs. One, division would be subtraction. Then I have the log of this h plus. So this becomes an equation. We are treating this as basically like x. Now I have the 4.5. So I'm going to solve this by subtracting my log of 1. And so I get 4.5 minus the log of 1 equaling negative log of h plus. Now here comes the tricky part. This is from before. Okay, what is the log of 1? This is something that you're going to know, but you might not realize you know it. Okay, so I'm going to bring this over here. And I want you to think back to if I gave you this. So log has a base 10, right? So 10 raised to the x is 1. So what power when we raise it is equal to 1? That should be 0. And so this is really 0. So we got 4.5 minus 0, which is 4.5, equaling our negative log of h plus. And so we're going to divide by a negative 1. And we are going to get negative 4.5 equals the log of h plus. Well, now in order to get just the hydrogen, we're going to change forms into exponential. So I'm going to bring in this 10. We got 10 raised to the negative 4.5 is going to equal our h plus. And that is how many hydrogen ions, and this would be in moles per liter. Okay. So let's change, let's do the same type, but I want to know from you what is the concentration of the hydrogen ions in orange juice. Okay, so go ahead, pause the video and complete. Okay, welcome back. You should have instead used 3, knowing that we have then the log of 1 over our hydrogen ions. Okay, I still want to see the work, even though we just did something very similar. Right, this is 0, so I can just leave that right there. We're going to divide by negative 1. And we get 10 to the negative 3rd moles per liter for our hydrogen ions. Okay, so using the properties to be able to solve and break down something might help manipulate it and be able to solve for a specific part of our equation. Okay. All right. Lastly, we're going to introduce the new vocab, but we're going to actually try this one and solving this to nearest thousandth. So it says express the solution as a logarithm, then evaluate. Okay, so this is one way to solve this problem. So we got x is in the exponent, right? But if I were to change this, right? So if I were to convert this to log form, in order to solve this, right, x is in the exponent, I want to change forms because logs equal the exponent. And so I would get log base 2 of 7 equals x. Well, the problem is I can't type into my calculator. So we'd have to do a different way. Okay, now there are some really fancy calculators that can do this. Okay, but typically we have a formula for this, and it's not overly complicated, but we're going to show you what actually happens. So what we do to one side, right, we can do to the other. So just like if I add 3, I could add 3 to this side. I can actually log both sides of the equation. Okay, so this is what I did, right? I'm logging both sides, which now means that this x is going to come in front if I use my properties. So I just actually created this as x times log of 2, which is going to equal log of 7, which is good for us because these are both base 10. So how do I solve for x? I'm going to divide by log of 2, and I can actually get and type this in my calculator. Remember, now this is log of 7 divided by log of 2. There's 2 logs in here. Okay, and I get approximately 2.807 is for the 1,000. Okay, so that is roughly what I got. Okay, so notice how this is what I would have had if I changed it to log form. This is what I did when I solved it, meaning that these two things are actually going to be the same. And so we're going to be able to use our change of base formula to get here faster. Now this always will work, okay, but sometimes people like it because it might be a little bit faster, less thinking about the log. Okay, so here is your change of base. This is your vocab word that's in on your vocab sheet. Okay, this is what you should see on there. This is what I want you to star. Okay, I also want you to put this in your notes. Okay, so I would just write exactly that. Change of base formula is equal to, if I take the log base b of m, that is going to be the log of m divided by the log of b. Okay, so I'm going to show this. M goes to the top. I want you to think b as in base, right, is the bottom. Okay, now this can be with any base. Okay, so I'm going to put a little a in here, and a is the new base. So for instance, they might say change this to base 5. Okay, well then a would be 5. They might say change it to base 10, right? If I want to put it in the calculator, so to type in calc, you need a base of 10. Okay, so let's take our example, right? We had 2x equals 7. We converted to log form, so I had log base 2 of 7. And so if I want to be able to type this in my calculator, this is going to now change to a base 10. The big number is on the top. The base goes to the bottom, but it becomes the big argument. And there is my change of base. Notice that this would be 10. Okay, now I could use anything. I could say same one, but change to base 5. Okay, it would not matter. We would still have log 7 on the top. We would have log 2 on the bottom, except this would now be 5. Now I couldn't type that in my calculator, but I might be able to, for some reason I want it in base 5. Okay, so this little a will change depending on what they tell you, or it could be any number, but it's the fact that you know that the 7 goes on the top and the base goes on the bottom. Okay, so this is a quick thing. I need you to show me this though, because I need to know what you're typing in your calculator. Okay, and we can always double check this, right? So if I plug that in, 2 raised to 2.807 in my calculator, right? So here was our original one. If I write 2 raised to 2.807, I get almost 7, which is what I could check. Okay, so let's do this one. Remember, I'm going to want to change this to log, which one is my base? That should be 3 to the 15th equals x. Remember, x is in the exponent, so I want to change it to log form to be able to solve this. This is an equation, right? And so now I can use the change of base formula. So I want you to show me this. Because I'm typing in my calculator, I don't need to write the 10, but this should be on your paper, and then you're typing in log of 15 divided by log of 3. Make sure you close your parenthesis. And we should get about 2.465. We round to the nearest thousandth with logs. Okay. All right, that concludes our lesson. Your homework for T6 L5 is on page 319, and you are responsible for 7, 9 through 11 all. You got 12 through 34 even, and 38, 39. All right. Thanks.